Hello again, this is Mr. Donahue. We're taking a look at pre-nuclear review problem. So after watching the video on reviewing pre-nuclear stuff, we're going to take a look at some of the practice problems that cover that material. Alright, so number one, which of the following phrases describes an atom? So if we're taking a look, is an atom a positively charged electron cloud? No. Alright, so I can eliminate this one right now because the electrons are negatively charged. So it can't be A. Is it B, a negatively charged electron cloud surrounding a negatively charged nucleus? No. Why not? Because the nucleus is not negatively charged, so that's not right. Is it a positively charged electron cloud? No, it's not it again. Or a negatively charged electron cloud surrounding a positively charged nucleus. That is absolutely correct, right? We have a positive nucleus and we have a negative electron cloud surrounding it. 2. Which group of atomic models is listed in historical order from the earliest to the most recent? So we know that we started with a hard sphere, and then we got, well, let's see what our options are. Wave mechanical, I know, was my last one. So where am I at? So this is going to have to be the latest one. So I can eliminate A and D, and I started with the hard sphere. So let's see, hard sphere model, electron shell model, and wave mechanical model. Yeah, it's looking like B, right? So we had a hard sphere, and we got now electron shells, and then the wave mechanical where we still have that positive nucleus, but it's more like a cloud of probability around it. Alright, 3. I'm changing my color. In the electron cloud model of an atom, an orbital is defined as the most probable, and this is just kind of a definition one, location of an electron. So it's just, that's it. Orbital is defined as the most probable location of an electron. 4. What was concluded about the structure of the atom as a result of the gold foil experiment? So the gold foil experiment, we had a sheet of gold foil and we're shooting some particles at it. Pew, 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 pew. Now, ideally, if you thought of as atoms as hard spheres, all of those particles would just be stopped by the brick wall of atoms. But what happened was most of them actually went right through, which they were able to detect. And then some of them got deflected and some of them bounced like straight back. So what they were able to conclude based on that is that we have a positively charged nucleus surrounded by mostly empty space, which looks like choice B, right? So that's how we know. The only way that works is if we have this positive nucleus and then we have mostly empty space in the atom. This is all empty, right? Cool. 5. Which conclusion was a direct result of the gold foil experiment? Again, another gold foil question. An atom is composed of at least 3 types of subatomic particles. No, we didn't know about neutrons. An electron has a positive charge? Nope. An atom is mostly empty space with a dense positively charged nucleus. Looks good. An electron has properties of both wave and particles. That is a true statement, but not of the gold foil experiment, so they tried to trick you with that. Alright, 6. In the diagram below represents bright line spectra of 4 elements, and a bright line spectrum produced by a mixture of 2 of these elements. Which 2 elements are in the mixture? So basically, each element is going to give off their own specific bright line spectrum. And if the element is in that mixture, it will have all of the bright lines of that element. So if I take a look, I'm going to start with lithium. You can see there's a bright line here, matches up with what's in our mixture. Same thing here. Cool, so it looks like lithium's in our mixture. Well, what other element is in there? So let me look at my mixture and go, all right, I got a line here. Hey, barium's got a line there. But if it's barium, then every line of barium needs to be in my mixture. So let's check. Barium, line there, line there. This looks like it's lining up pretty good. Yeah, it looks like all those lines that are in barium are in our mixture, which is good. So barium and lithium. Now hydrogen may have a line that's also in there, but if hydrogen was there, then all of hydrogen's lines need to be there and they're not. 7. The isotopes K37 and K42 have the same what? Well, they're the same element, but they got different masses. And the reason that they got different masses is because they have a different number of neutrons. So they don't have the same number of neutrons. Do they have the same decay mode? No, you can look it up on the reference table for nuclear stuff when you get there. They are different decay modes. Same bright line spectrum? They sure do, because they are the same element. And bright line spectrum are like fingerprints. And the same mass number for their atoms? No, that's not true. 8. Which subatomic particles are located in the nucleus of a neon atom? So what's in the nucleus? Protons and neutrons. Electrons are on the outside, right? So if I got my nucleus, I got protons, I got neutrons, and on the outside I have the electrons. So you need to know that. 9. What subatomic particle is negatively charged? Another just kind of factual one. It's the electron. right? So neutron has a charge of 0, positron has a +1 charge, so does a proton. The electron is the only one with a negative charge listed there. 10. The greatest composition by mass of O17 is due to the total mass of its what? So if I'm taking a look, all right, I got O17. I look up oxygen. It has an atomic number of 8. So if it has a mass of 17, let me think about this. The mass is from the protons and the neutrons. So if it's got an atomic number of 8, I know there's 8 protons, plus some number of neutrons has to equal 17. So that tells me that I have 9 neutrons. So most of the mass is from the neutrons, because 9 is greater than 8. 11. The total mass of the protons in an atom of gold, 198, is approximately, oh geez, I should have looked this up. Gold, Au, 198. And Au has an atomic number of 79. So if I'm taking a look at Au, how do I get 198 as the mass? Well, remember the mass has to equal the protons plus the neutrons. And if the mass equals 198, it has to equal 79 protons, because that's the atomic number, and some number. So let me do the math. 198 minus 79, and I'm going to have to do the long version. 18, that's 9. And that's, there you go, 119 neutrons. So let's see. Total mass of the protons, I didn't even have to do that much. Look at that, it's just 79 atomic mass units. 12. Which statement compares the masses of two subatomic particles? So let's just review. We got protons with a mass of 1 and a charge of 1. We have neutrons with a mass of 1 and a charge of 0. We have electrons with a mass of 0 and a charge of -1. So which one of these statements is the correct statement? It's going to be choice B. The mass of the proton is greater than the mass of an electron. 13. Which quantity identifies an element? So what determines the identity of an element? So what identifies it? Protons. It's the number of protons, which is the atomic number. This is just kind of definition stuff, some low-level rote stuff that you need to know. So commit that to your brain. Do it. 14. Which part of a helium atom is positively charged? So again, what has a positive charge to it? You should know that, commit it to memory, the nucleus. Because in the nucleus, we have protons and we have neutrons. Remember, neutrons are neutrally charged with a mass of 1, whereas protons have a positive 1 charge and a mass of 1. So what has positive charge? The nucleus. 15. Which statement matches a subatomic particle with its charge? So again, review. Protons have a mass of 1, a charge of 1. Neutrons have a mass of 1, charge of 0. And electrons have a mass of 0 and a charge of -1. So which one of these is matched up correctly? It's going to be C. Neutron has no charge. Neutron is neutral. 16. What is the mass number of an atom that has 6 protons, 6 electrons, and 8 neutrons? So let's take a look at this. Remember, the mass is going to be the protons plus the neutrons. And why is that? Well, because the electron has a charge of -1, but its mass is so small that we just say it's 0. So let's figure this out. How many protons did it say we have? 6. So 6 protons plus 8 neutrons, and we can ignore the electrons. So that tells us I have a mass number of 14, choice D. The most common isotope of chromium has a mass number of 52. Which of the following notations represents a different isotope of chromium? So it's got to be something that's not 52. So chromium has an atomic number of 24, so that needs to be the same, but we need to have not 52 up top. So I'm taking a look. The only one that could be different, B, right there. There you go. That's an isotope. 18. Which isotopic notation represents an atom of carbon-14? So remember that C, that 14 is the mass, which when you write it a different way becomes up there. So I got carbon, the mass of 14, and the number that goes down here is the atomic number. So I look it up. What's the atomic number for carbon? It's 6. So what is it? Boom, chakalaka, choice C. All right, number 19. An atom of any element must contain an equal number of protons as electrons, because the whole thing has to balance out to be 0. So if I had 6 protons, that means I have plus 6 charge. To neutralize that positive charge, I need 6 electrons, so I end up with a minus 6 charge, and then the whole thing is neutral. So that is 19. 20. Magnesium and calcium have similar chemical properties because an atom of each element has the same total number of what? Chemical properties determined by the outermost shell, or the valence electrons, because that is what's actually reacting with other stuff. It's the very outermost thing in an atom, so those valence electrons determines the chemical properties of an atom. All right, 21. What is the, an atom in the ground state contains 5 total electrons, 5 protons, and 5 neutrons. So if I'm talking about what is the electron dot diagram, well, I got to figure out, all right, in the nucleus I have 5 protons, I have 5 neutrons, and on the outside I have 5 electrons. Remember, that first energy level can only hold 2 electrons, so the rest of them have to go into that second energy level. So it's 2-3, and if we're doing a dot diagram, we're only interested in the 3 valence electrons, so it's going to be choice A. 22. Which of the following statements describes the relative energy of the electrons in the shells of a calcium atom? It's going to be choice D. An electron in the third shell has more energy than an electron in the second shell. So if I'm taking a look, this is my nucleus, and these are my shells that the electrons can be found in. The lowest energy is going to be one closest to the nucleus, and the highest energy is going to be the one furthest away. As it falls from the outer shells into the lower shells, it gives off energy in the form of light. How big of a drop determines what wavelength of light is being emitted. All right, 23. Which electron configuration represents an atom in an excited state? So we got to take a look at our reference tables and see what the ground state is. Normally, you can have 2-8-8-2 kind of as your ground state. So you fill in the first energy level with 2, and then you go into the second energy level, you put 8 in there, before you go into the third energy level and put 8 in there. So if we take a look, which one of these doesn't match that, we're going to see it's going to be choice B. This could have been 2-8, but it was excited, and 2 of those electrons jumped up to a higher energy level. So 2 went into the third, which means we have 6 left in that second energy level. So this 2-8-1, still the lowest, 2-7, still ground state, 2-8-8-2, still ground state. The only one that doesn't fit is choice B. All right, 24. Naturally occurring boron is composed of 2 isotopes. Percent abundance and mass of each isotope are listed below. So there you go. Calculate the atomic mass. So again, weighted average atomic mass is going to equal the percentage, so 19.9, times the mass, 10.013, plus the same thing but for the other isotopes, so 80.1 times 11.009, and then because we're dealing with percentages, once we add those together, we divide by 100 because it's percent per 100, and we end up with an answer of 10.875677 atomic mass units, or grams per mole. 25. State in terms of subatomic particles how an atom of carbon-13 is different from an atom of carbon-12. So they have different number of neutrons. Or, being more specifically, if I have carbon, its atomic number is 6. If it has a mass of 12, it's got 6 protons and 6 neutrons. And if I had a carbon-13, the only thing that's different is the mass. So I still have 6 protons, but this one has 7 neutrons. So I could be more specific. I could say carbon-12 has 6 neutrons and carbon-13 has 7 neutrons. 26. Explain in terms of protons and neutrons why uranium-235 and 238 are different isotopes of uranium. So why are they isotopes? Well, first, they have the same number of protons, but they have different number of neutrons. That's it. That works. 27. Write one electron configuration for an atom of silicon in the excited state. So I got to look up what is the electron configuration for silicon normally. Well, it's 2-8-4, and that is the ground state. All right. So the excited state, one of those electrons gets bumped up to a higher energy level. So I could have excited one from the second energy level up to the third. I could have gotten 2-7-5. that works. Or I could have excited one that was in the third to the fourth energy level, and it could be 2-8-3-1. There's a lot of different things that you can do. You just got to make sure that this stays maximum 2, this is maximum 8. Those are really the things you got to look out for. So I hope you found that helpful. See you in class. Bye.